Assalamualaikum. My name is Muhammad SYAFIQ bin Muhammad JURID. My metric number is CN 2013. Okay, today I want to present a belt friction for introduction. Okay, the rope belt friction apparatus is similar to the belt friction, which explains the force that exists between a belt and surface, such as a belt wrapped around a ball rod. When one end of the belt is pulled, only a portion of the force is communicated to the other end, which is wrapped around a surface. The friction force is increased as the quantity increases. Wrapping a belt around a surface causes a tension in the belt to differ both ends. The apparatus rope belt friction is made up of a wall-mounted fixed pulley with a loaded belt, rope, flat belt, wheel belt, and wrongly and correctly fitted. A wake hanger and standard size wake. This piece of equipment is part of a set meant to demonstrate and experimentally prove fundamental engineering principle. The setup time is short and all measurements are taken using the simplest feasibility apparatus, allowing the student to focus on their study. The only engagement is with the engineering principle be taught. In reality, the theoretical tension operation of the belt or a rope, as estimated by the belt friction equation, may be compressed to the maximum tension that the belt can withstand. This allows a rig designer to determine how many times the belt or rope must be wrapped around the pulley to keep it from slipping. When performing fundamental activity, mountain climber and sailing crew display a common understanding of the belt friction. Okay, thank you.
Assalamualaikum. My name is Muhammad SYAFIQ bin Muhammad JURID. My metric number is CN 2013. Okay, our topic for practical task video is belt friction, and the objective simulate belt friction phenomena and the mode of operation of the belt drive. Second is to investigate the following relationship between the belt force, coefficient of friction, and art of the contact. Third point is the coefficient of the friction for various material and the difference between flat belt and V belt.
Morning, my name is Muhammad bin SYAFUDDIN. My matrix number is CN200041, and today I'm going to explain about the equipment for the belt friction. So the first one we have is the pulley. The second one is the hand crank. We have the spring balance, the threaded stem, and there are two spring balance, and then we have the belt support, the column, the base plate, and we have this one is the swindle type belt holder, and we have this one is the pin lock, and then we have three types of belt. This one is the hem, this one is the nylon, and this one is the leather belt. So that's all from the equipment setup.
For the procedure, first thing first, we need to tighten the thread screw and put the spring balance both sides. Then we need to lock the hem on the V-belt. Then we need to adjust the spring balance both sides and make sure the hem is tight. After that, we need to spin the pulley anti-clockwise. Repeat this procedure for angle 60 degree, 90 degree, 120 degree, 150 degree, and lastly 180 degree. For the second experiment, we need to use nylon belt on the flat belt and the angle is fixed only 180 degree. Then we need to take the measurement both spring balance. And after all done, we need to change the nylon belt to leather belt. So that's all from me.
Assalamualaikum. My name is Izzat Hakimi from section 1. So right now I'm going to share about our practical task for belt friction. So we are from group 4. So first I would like to share about our observation. For the observation, there are 2 experiments that need to be done. Okay, first, the objective is to demonstrate the validity of a tailwind rope friction equation. The data collection will start from 10 Newton as being set on the spring balance. The value of F1 is increased, meanwhile for F2 will decrease where the lowest value is 4 Newton. Next, we will find the ratio value of F1 divided with F2. So the second experiment, we will use various material to find the value of force 1 and force 2. Also, we need to find the value of coefficient of friction for each material, which is leather, hemp, and nylon. Next, the reading of every material is very different, and after that, with all the data, we will calculate the coefficient of friction using the formula. So this is our data result for experiment 1, and this is the result for the second experiment with the material combination. So the calculation section, so we can see that for the first figure is the calculation for ratio F1 divided with F2. Next, the second figure is the calculation for the coefficient of friction for leather, hemp, and nylon. So this is the graph for the ratio of F1 divided with F2 for measured and calculated, where we can see the ratio is increasing. The same goes for the calculated, where the value will be increased. Okay, so for the discussion, for the first experiment, we can infer that there will be a difference between 2 forces with F1 having a higher value. The statistics show that 4 Newton at an angle of 180 degree has the lower value for F2, while the value of F2 is decreasing. Meanwhile, for the second experiment, the reading for F1 and F2 spring balance are substantially different. The reading for F1 being 40 Newton and F2 being 30 and 4 Newton respectively for hemp and nylon respectively. So during the experiment, there are some error that we need to face, which is the first one, the challenge to determine whether the pulley are moving with a constant acceleration simply by observation and without having any measurement or technique to measure it. The second issue is the nylon rope is not completely elastic, so it will produce a frictional force with both the pulley's surface and with itself. So the way that we need to overcome this issue, first, the trials need to be repeated in order to get average reading. The second way is we need to keep the nylon rope for being wound too tightly because it can rotate quickly. And last, the way to overcome is to keep the nylon rope and pulley surface from coming into contact with each other too often. Okay, last but not least, the conclusion for this project experiment. So we have 4 conclusions that can be concluded, which is the first one, the objective for the experiment have been achieved, which is to stimulate the belt friction and the mode of operation of a belt drive. We also able to understand the relationship between the belt force, coefficient of friction, and arc of contact. Based on the graph that have been done, we know that the angle play a big role to determine the value of each ratio. Finally, the experiment for various material that have been conducted also show that each material has a different driving force. Okay, that's all from our group, which is group 4. Thank you.